and look at the quotient of two functions. So just like before, one notation is like this, another notation like this. You can also see this as sometimes you will get one notation like this, or you could have the notation like that. And we start by using the same strategy that we use for multiplying. We start with nice points. Here I have a nice point. The red one's 2, 2, the blue one's 2, -1. If I divide those ones, I'm going to get this point right here at 2, -2. Wherever the function on the top is equal to 0, just like multiplying, that's going to stay 0. However, with dividing, what we add to the mix is that whenever the function on the bottom is equal to 0, that's a non-permissible value. And at non-permissible values, sometimes we're going to get asymptotes, sometimes we're going to get wholes. And it's not necessarily easy to tell right away what's going to happen. Asymptotes happen more often, so I would say start by drawing an asymptote. If it turns out to be a whole later, you can always get rid of that, or you can just leave it there. It really doesn't matter. Okay? For the most part, when the only time you're going to get a whole is when both the red and the blue graph are 0 at the same time. Then you're going to get a whole. Well, not always, but most of the time you'll get a whole at that time. However, if the red graph is not equal to 0 and the blue graph is 0, that will always result in an asymptote. So in this case, this is going to result in an asymptote because the blue graph is going to get closer to 0, the red graph gets closer to a value, so that means your function is going to go up and down forever. Now finding out some other points. Some other points that are really nice on this one besides the nice points. So once you've gone through and done all of the nice points, here's another green point that I would label. I would look where my red graph and my blue graph intersect. Why is that helpful? It's 1. Why is it 1? If f of x and g of x intersect, that means that they're the same value. So if they're the same value divided by same value is going to equal 1. So even though those aren't nice points, they are another point that you could graph. You could also look where g of x, the bottom function, is equal to 1. Because what happens when I divide by 1? Stays the same. So, I mean, that's really close together to that other point, but that would stay the same. The hard part in the dividing ones is to find out, does this, as it gets bigger, what happens to the y values? Because I'm doing f of x, which is a square root graph, divided by g of x, which is a line graph. And so as x gets really, really big, if you analyze this, can you see that the bottom gets bigger faster than the top? Like if I put in 1,000,000, I'm going to have 1,000,000 on the bottom, but only a square root of 1,000,000 on the top. And so the bottom will get bigger faster. And that will result in our graph getting closer to 0. Again, for the domain is x is bigger than or equal to 2 for the red graph, and the domain is everything for the blue graph, but the domain of our green graph, it's still the overlap, but you also have to add whatever the non-permissible values are. That's right. So there is an asymptote here at y equals 0. And that asymptote, remember, horizontal asymptotes just tell us what happens at extremes. Because this point right here is at 0, and that's okay. So our domain is going to be the overlap, and you're going to add your non-permissible value in your domain, saying that x can't equal 1. Look at that green graph. What is the range of that graph? So you want to use, are you using set notation? Okay, so you're saying negative infinity, what kind of bracket would I put with that? Round 1, okay. Like this? Okay. What kind of bracket with that, 0? Square? So what he did is he looked at the two different pieces. This piece went from negative infinity to 0 and didn't include 0. And then this piece started at 0 and went to infinity. Okay, good. Can anybody write that in a different way? Is that crazy? It's everything. This is not wrong. This is right. This is a lot simpler way to write it, but it feels weird to say it's everything when it's broken up the way that it is and it has an asymptote. How is it everything if it has an asymptote? Well, if you say it's everything, you're saying that there's nothing that's not included. If you say that it should be written with something not included, what value is not included? You want to say 0 is not included because of that asymptote. But I have 0 right there. Even though it's broken up into different pieces and it's not continuous, the range is still everything. I mean, there was some graphs that were broken up into different pieces that it was really easy to see the range was everything. Remember those graphs? You had some graphs that look like this. Something crazy like that. That graph is easy to see that it's everything because the middle section went right through. This one still is everything, even though that middle section, there's no middle section. There's no point that continues all the way from top to bottom. Okay, that was just interesting. Let's do example 2, and then I'll give you some time to work on some of these. We've got a square root graph and a line. State the domain and range of each of them. So I'll make this one my red graph, this one my blue graph. For f of x, the domain bigger than or equal to 0. The range bigger than or equal to 0, right? We know what that shape of that graph looks like, so we can say the domain and range quickly. For g of x, it's a line. The domain is everything. The range is everything. If we wanted to, we could draw that line to imagine it. Part B, we're going to take f of x and divide it by g of x. So the explicit equation is in terms of x only. F of x is the square root of x. G of x is x minus 2. That would be our explicit equation. And we want to figure out the domain and range. So the domain is going to be the overlap of the two. So the overlap of the two says it only makes sense if x is bigger than or equal to 0. And then we have to check with dividing, are there any non-permissible values? And in this case, what can't x be? X can't be 2 because then you would divide by 0. To figure out what the range of this graph looks like, we could add our asymptote and we could look at some values. What happens when you plug in 0? Because the domain is x is bigger than or equal to 0, so we'll start with 0. 0 divided by negative 2 is 0. What happens when you plug in 1? 1, negative 1. What's the next nice number you could plug into here? 4. If you plug in 4, get 2 on the top, 2 on the bottom, 2 divided by 2 is 1. Wanted to plug in 1 more, the next nice number you could plug in would be 9. You'd get 3 sevens. Does it make sense when x gets really, really big that the bottom gets bigger than the top? So there's going to be and the range is everything. Because 0 is included here. Because when I plug in 0, I got 0, comma 0. So I have a y value that's equal to 0. 6, 13, and 16